Ever been stumped by a variable frequency drive or VFD that just won't cooperate? You're not alone. These intricate devices are known to perplex even the most seasoned technicians. The common issues that often arise with VFDs range from overheating to motor noise and even unexpected shutdowns. Each of these problems can cause significant disruptions and delays, whether you're working on a small-scale project or managing a large industrial operation. Understanding how to troubleshoot these issues is paramount. It's not just about fixing the problem at hand, but gaining the knowledge and skills to prevent future disruptions. The ability to identify and rectify VFD issues efficiently can save you time, resources, and a whole lot of frustration. So, buckle up and get ready to delve into the world of VFD troubleshooting. By the end of this video, you'll be a pro at diagnosing and fixing these pesky VFD problems. Before we dive into the troubleshooting process, it's essential to understand what VFDs are and how they work. VFD stands for Variable Frequency Drive. These clever bits of kit are primarily used to control the speed and torque of an AC motor. They do this by varying the frequency and voltage supplied to the motor. But how exactly do they achieve this? Well, the magic lies in their three primary components: the rectifier, the DC bus, and the inverter. Let's start with the rectifier. Its job is to convert the incoming AC power to DC power. This is crucial because while our power supply is AC, the VFD needs to control it in a more precise way than AC allows. This is where the DC power comes into play. Next in line is the DC bus. Consider this as a kind of holding area for the converted DC power. It's here that the voltage is smoothed out and prepared for the next stage. Essentially, the DC bus ensures a steady, unbroken flow of power to the final component of our VFD. And that brings us to the inverter. This is where the real magic happens. The inverter takes the steady stream of DC power and flips it back to AC. But not just any AC. This is AC with a variable frequency and voltage, which is the key to controlling a motor's speed and torque. So to sum up, the rectifier converts AC to DC, the DC bus holds and smooths the DC power, and the inverter converts it back to AC. The resulting AC output has a variable frequency and voltage, which allows for precise control of the motor's speed and torque. Understanding these components and their roles in the operation of a VFD is vital for anyone looking to troubleshoot issues with these devices. It's like trying to fix a car without knowing what the engine does. You could do it, but it would be a lot harder. With this understanding of VFDs, we are now ready to tackle any issues that may arise. Now, on to the first step of the troubleshooting process: observation. The power of observation cannot be underestimated when it comes to troubleshooting variable frequency drives, or VFDs. It's often the case that the smallest signs can lead to the most significant discoveries, helping us pinpoint the root cause of an issue. Our first port of call in this phase is to check for visible signs of damage. This could be anything from a burnt-out component, discolored wires, or even a cracked casing. Each of these signs can provide valuable clues about what might be going wrong inside the VFD. Remember, we're detectives on a mission, and every little detail counts. Next, let's tune into the sounds around us. Unusual noises can often indicate problems. A buzzing or humming sound could imply an electrical issue, while a clunking noise might suggest a mechanical fault. Be sure to listen carefully. These noises are the VFD's way of communicating with us. Lastly, we turn our attention to the motor behavior. Is it running hotter than usual? Is it vibrating excessively? Or perhaps it's not running at all? Observing the motor's behavior can offer us insights into the internal workings of the VFD. For instance, a motor running too hot might indicate that the VFD is supplying too much voltage, while a motor not running might suggest a problem with the power supply. Observation is a powerful tool in our troubleshooting toolkit. In this phase, we're gathering as much information as we can to help us identify potential problems. It's like piecing together a jigsaw puzzle. Each piece of information brings us one step closer to seeing the bigger picture. But remember, observation isn't just about looking, listening, and feeling. It's also about understanding what's normal and what's not, what's expected and what's unexpected. The better we understand the VFD and its components, the more adept we'll be at spotting anomalies. Remember, the devil is in the details. Never skip this crucial observation phase. Once you've made your initial observations, it's time to dive deeper with the second phase, testing. In this phase, we're going to use some tools of the trade, such as a multimeter, to probe deeper into the variable frequency drive, or VFD, checking for issues in the power supply, control signal, and motor output. The multimeter, a versatile tool, can measure voltage, current, and resistance. It's a staple in any technician's toolbox and a key player in our troubleshooting journey. But before we start testing, let's take a moment to discuss safety. Safety is paramount when dealing with electricity. Always ensure the VFD is powered off and disconnected before testing. Also, protective gear like gloves and safety glasses are not just fashionable, they're essential. Now, let's start with the power supply. We'll use the multimeter to check the input and output voltage. If the readings are not within the manufacturer's specifications, it could indicate a problem with the power supply. Next up, the control signal. This is the brain of your VFD, dictating its speed and direction. We can also use the multimeter to test this. If there is no control signal, or if it's inconsistent, it could mean your VFD is not getting the right commands. Lastly, we'll check the motor output. This is where the rubber meets the road, or in our case, where the electricity meets the motor. Again, we'll use the multimeter to measure the voltage and current supplied to the motor. If these are not within the manufacturer's recommended range, it could mean the motor isn't getting enough power, or maybe too much. Remember, testing is a process of elimination. It helps us narrow down the possible causes of the problem until we find the culprit. It's like being a detective, but for electrical equipment. By methodically checking each component, we can pinpoint the source of the problem, bringing us one step closer to a solution. With the problem identified, we now move on to the final phase, rectification. In this phase, we're going to address the most common issues you might encounter with your VFD. The first step is often replacing damaged components. This is where your keen eye for detail really comes into play. You'll need to identify the faulty part, order a suitable replacement, and then carefully install the new component. Remember, it's essential to ensure that the replacement part is compatible with your VFD. Next, let's talk about adjusting the VFD settings. This can often resolve issues, especially those related to performance or communication. You may need to adjust the speed, torque, or voltage settings, for example. Always refer back to your VFD's manual for specific guidance. It's a treasure trove of information and can provide the precise parameters to get your VFD humming along smoothly again. If replacing components or adjusting settings doesn't resolve the issue, it's time to consult with the manufacturer. This might seem daunting, but remember, they're the experts. They've likely encountered your problem before and can guide you through the necessary steps to rectify it. Now, while we're talking about rectification, we can't forget about safety. Troubleshooting a VFD is not without its risks. Always ensure the device is powered down and disconnected before starting any work. Wear appropriate protective gear, and if you're unsure about anything, don't hesitate to seek professional help. It's better to be safe than sorry. Finally, after you've rectified the issue, it's important to test your VFD thoroughly. Run it through its paces, check all the functions, and make sure it's performing as expected. This is the moment of truth, the culmination of your hard work and meticulous troubleshooting. With the problem rectified, your VFD should now be back in top shape. And with that, you've successfully navigated through the final phase of the troubleshooting process. Well done. So there you have it, a step-by-step guide to VFD troubleshooting. We began by understanding what a variable frequency drive is and how it functions, underlining the importance of a strong foundational knowledge. Next, we emphasized the crucial role of observation in the process. Being keenly aware of any unusual sounds, smells, or behaviors can give you vital clues about what might be going wrong. We then broke down the troubleshooting process into 3 phases. Phase 1 put a spotlight on preliminary checks and the use of a multimeter to measure voltage and resistance. In Phase 2, we moved on to more advanced testing, focusing on checking the input and output power sections. Finally, Phase 3 covered rectification, where we discussed how to replace faulty components and restore your VFD to optimal working condition. Remember, practice makes perfect. With these steps in mind, you're well on your way to becoming a VFD troubleshooting expert.